Throughout this training, or at any time you need support, there are many ways to contact us. You can follow us on all major social media platforms or email us directly via our website, or you can click the Cancel Connect icon shown at the bottom of this slide on our website to book a consultation with one of our experts. The box plot. It's a convenient chart to display similar information as the histogram, but in a different way. The box plot takes a set of continuous data and breaks it down into the 5-number summary so that we can compare the center, shape, and the spread between different groups of data.
There's sometimes confusion with box plots that comes from the whiskers. Can you explain that to us, Claire?
Yeah, box plots' whiskers are mistaken as error bars more often than you think, especially when there are asterisks representing outliers on top of them. Well, they're not. They show the lowest and the highest quartiles of values. They contain half of the data points. The other half are in the box. The key question that we're asking when using a box plot is, are the groups different? And if so, how?
An easy pattern to interpret is groups with non-overlapping boxes. In this scenario, we can conclude that the groups are, in fact, very different. If they do overlap, we'll move on to the lines inside the boxes.
The middle lines are the medians, or the middle values of each group. If the median line of one box lies outside of the other box entirely, then there's likely to be a difference between the two groups. In this example, the boxes overlap, but don't spread past both medians, so the groups are likely to be different. If both median lines lie within the overlap between the two boxes, we'll have to take another step to reach a conclusion about the groups.
Now we're talking about the whiskers. The lines coming out from each box extend from the maximum to the minimum values of each set. Together with the box, the whiskers show how big a range there is between those two extremes. Larger ranges indicate wider distribution, that is, more scattered data. The same thing can be said about the boxes. Short boxes mean their data points consistently hover around the center values. Taller boxes imply more variable data. That's something to look for when comparing box plots, especially when the medians are very similar. Wider ranges, like wider whisker length and box size, indicate more variable data. So the keys to understand whether the variation is acceptable is to compare it to customer or business requirements. So while these three groups share the same center, median, point, or median, we can clearly see in which groups the variation is unacceptable.
We learned about outliers in a control chart, and box plots are another chart that illustrates outliers. When there are outliers, they are shown as dots or data points outside the whiskers. Not all data sets have outliers. Data points have to go above or below the box pretty far to count as outliers. How far? 1.5 times the size of the box. The box is the IQR, or interquartile range, and that number is multiplied by 1.5 to determine the threshold for an outlier.
It gets tricky when the boxes overlap and their median lines are on the inside of the overlap range. As always, maths comes to the rescue. Woohoo! Follow the simple formula in your workbooks. The distance between medians divided by the overall visible spread times 100. The answer you will get will tell you if there is likely to be a difference between the two groups. It's significant if the results is over 33% for a sample size of 30, over 20% of a sample size of 100, or over 10% for a sample size of 1,000. Since we are mentioning sample size, let's not forget that box plots are about range, not actual counts.
At first glance, It's easy to think that a longer section on a box plot represents a higher count of data points, but that's not the case. Take a look at this box plot. Each section contains exactly the same number of data points, a quarter of the whole group. The different sizes come from how variable the values are in each section. If they're far apart from one another, the section grows longer, which leads us to talking about skewness.
Box plots can be skewed to the right or to the left. When the right side of the box and whisker plot is longer, it is skewed to the right. The values on the side, the upper end of the scale, are more variable. Most observations concentrate at the low end of the scale. When a box plot is left skewed, values gather at the upper end, making a short and tight section there. To the left of that crowd, data points spread out, creating a longer tail. Box plots are like the base of the distribution curves. Skewness suggests that data may not be normally distributed.
And a quick one-page lesson on the box plot.
Boom!
Let's give the box plot a little love and bring it to life in your projects. It's a really great chart if you know how to use it. And now you're one of the exclusive group of people who knows just that.
It has been our sincere pleasure being with you through this part of the training, and we thank you for your dedication to creating a better workplace and an environment that you can truly enjoy.